This is an introduction to Experiment 3A, Determination of a Chemical Formula. In this experiment, we will react zinc and iodine to produce the compound zinc iodide. We will do this with amounts of zinc and iodine such that all of the iodine is reacted, and we will have some zinc left over that is unreacted. So first we will we'll weigh a flask. So we'll have a mass of a flask, some amount of grams, and then we'll put some zinc into the flask and weigh the flask again. So then we'll have the mass of the flask plus zinc, and that will have a certain mass. Now, these calculations are not hard, but they can be confusing. So I want to show you how you can use the words to help you figure out what to do with the numbers. We want to find the mass of the zinc. So if we take the words here, flask plus zinc and flask, and subtract words, then we end up with zinc. And so if we subtract the mass of the flask from the mass of the flask with the zinc in it, we will get the mass of just the zinc alone. Next, we will add some iodine to the flask, and we'll weigh it again. So now we're going to have flask plus zinc plus iodine. That'll be our new mass. And to get the mass of just the iodine, we want to subtract the mass of flask and zinc. So we can separate the words, subtract the words, and find the mass of iodine. Once we have the masses of the reactants, we'll add some methanol to the solution to provide a medium for it to react in, because they won't react just sitting there as solids. When we add the methanol, what we'll notice is the solution will turn a very dark brown color, much darker than that. Ooh, I can make it darker, look at that. A very, very dark brown color, almost look like coffee. That dark brown color is from the iodine that's dissolved in the methanol. Then we'll take this flask and put it on a hot plate and heat it. And it's going to take about half an hour. And in the video, I did it time-lapse, so you don't have to sit and stare at it like I did. And what you'll see is that the solution color gradually fades. When the solution color is almost colorless, just a very faint yellow color, then we know that all of the iodine has reacted. So the mass of iodine that we added to the flask is the mass of iodine that reacted. We added zinc, but we added extra zinc. So what we'll see in this flask is that the iodine is gone, and some of the zinc is gone, but some of the zinc is remaining. So afterwards, we will have the flask. Sorry, the flask is changing shape a little bit because I'm not an artist. And what we'll have in here is a little bit of zinc. So this is the unreacted zinc. We will separate the solution, which contains the zinc iodide that's dissolved in the liquid, by decanting and then washing the unreacted zinc. Then we can dry it and find the mass of the unreacted zinc. To calculate the formula, we need the mass of zinc that actually went into the compound. And so we'll take the zinc that was added, and we'll subtract the unreacted zinc. and that will give us the reacted zinc. And this is the mass we need to calculate the empirical formula. Remember, the steps for calculating an empirical formula is you need the mass of each element, then you convert to moles. So you get moles of each element, and then you get the mole ratio. Take the larger number and divide it by the smaller number. Hopefully you'll end up with a nice whole number, and that will be the subscript for the element that there's more of. In addition to calculating the empirical formula, we're also going to look at a couple of things. We're going to look at, I'll just scroll up here. We're looking at the mass percent zinc in the compound. So we can do this experimentally because, what happened? There, I'm sorry, scared me. This is going to equal the percent zinc is going to equal the grams of zinc divided by the grams of the compound. And always times 100 to make it a percentage. The grams of zinc here, those are the grams of zinc that reacted. The grams of zinc iodide is the mass of the compound that we isolate at the end. So we poured that liquid off that contained the zinc iodide into a beaker, and then we evaporated all the methanol. And so we get this new compound at the end, and we can find the mass of that. So these two numbers here are directly from your experiment. We can also calculate the theoretical percent mass of zinc. And we're going to do this from the chemical formula. So the correct formula is ZnI2, and hopefully the data will give you that as well. We can calculate the percent zinc here by taking 1 mole of this compound and finding the grams of zinc divided by the grams of the whole compound. So this is just going to be the molar mass. And again, times 100. Then we're going to compare the experimental to the theoretical. And we're going to use percent error to do that. And a reminder that percent error is equal to the experimental value minus the theoretical or accepted value divided by the theoretical value times 100. The lower the percent error, the more accurate the result. We can also use this experiment to demonstrate the law of conservation of mass. So going back up here and looking at our little word equation here, the law of conservation of mass says that the mass of the reactants must be equal to the mass of the products. So if we take the mass of zinc that was added and we add the mass of iodine that was added, that's going to equal the mass of the reactants. And if we get the mass of the zinc iodide produced and add the mass of the unreacted zinc, that's going to give us the mass of the products. If everything worked perfectly, those two numbers would be exactly the same. Of course, this is a real-life situation, and so it's not going to be perfect. So we can compare those numbers, and again, we're going to use percent error. So we're going to use the mass of the reactants as the theoretical value, or the accepted value, because that's what the mass of the products should be. So we're going to take the mass of the products, percent error equals mass of products minus mass of reactants divided by the mass of reactants times 100. And again, the smaller the percent, the better the results.